Okay, so this is an additional video just to show you the relationship of these quantum numbers to the electron cloud model of an atom. So again, we have said that an atom will not simply look like a solar system, planetary model wherein you have the nucleus in the middle and then surrounding it will be the electron. So that is not really an image of an atom. So there is Schrödinger and Heisenberg who developed a model of an atom that uses the electron cloud. So we have said a while ago, we discussed about the quantum numbers, and for the principal quantum number, that is the main energy level, or that will tell you the size of the orbital. Okay, for the angular momentum, that will discuss about the shape of the orbital. For magnetic, the orientation, and then for the electron spin is the spin, either clockwise or counterclockwise. Now, how does an electron cloud model of an atom really look like? So going back to angular momentum, we have said that this is actually the shape of the orbits. There are different, what are the orbitals? What are the subshells that is present? So let's say, for example, we have this specific information about one electron, and that is 3p3. Okay, 3p3. Now, this is the n, or principal quantum number. This is the subshell, or the angular. There is also an orientation, and then there's also the electron spin. Now, how does this 3p3 look like? Okay, or let's say, where is my periodic table? So let's say we have beryllium. Beryllium will have, the atomic number is 4. So if you're going to do the electronic configuration for that, that will be 1s2, 2s2. Okay? Now, what does the beryllium look like? What does an atom of beryllium look like? It's based from this information. So we have this information over here, 1s2, 2s2. So inside beryllium, if we're going to draw it, very simple drawing using the orbital, what do you call this one? The orbital model. Beryllium will look like this. So there is proton inside, there is neutron, and then outside we have these electrons. So in the first orbit, or first orbital, okay, there are 2 electrons. The second energy level, 1, and then the second energy level, 2. There are how many electrons? There are 2. So it's like that. Okay? But an electron cloud model will tell you differently. So let's see. Be. So inside the nucleus, there is proton, of course, and there is neutron. What does an electron cloud look like? Now, we have said subshells. Okay, the subshells will have different shapes. The angular momentum will tell you the shape. And we only have S, P, D, F. There is different shapes for the different subshells. For the S, this is the shape of S orbital. For P, the shape for that is a dumbbell shape. Yeah, this one, dumbbell. So it could be in different orientation. It could be drawn, the P. Okay, let me draw it here. So the P subshell can be drawn in different orientation. Okay, along Y, along X. So it could be written along Y, ganyan, dumbbell. So it could be like this. It could be drawn along X. Okay, along X. So nakahiga. And then the other one is written along Z. Okay? Written along Z. So, diagonal. Okay, it could be diagonally. Dumbbell. It doesn't look like dumbbell. So, this is called PY. This is PY because it is along the y-axis. This is the PX because it is along the x-axis. And this is PZ because it is along the Z or diagonal line. Okay, so P can be either oriented like this one, but in general it is in dumbbell shape. And then for D, the shape for D is like a clover. So 1, 2, 3, 4, and so this is the y-axis and then x-axis. It looks like a clover. And then for F, it could be 6 lobes or 8 lobes. So sometimes they can look like this. So parang 1, 2, 3, 1, 2, 3, like that. Or sometimes there are 8 lobes. 1, 2, 3, and then there's 4 on the other side. Let's imagine that this is a three-dimensional. So 1, 2, 3, and then there's the back part. So 8 lobe F. So S, circular, just a simple circle. P, a dumbbell shape. D, clover shape. F could be 6 lobe or 8 lobe. Alright, so let's try to draw it. Okay, beryllium. So for beryllium, okay, 1s2. It says here, if this is the nucleus of the beryllium, inside there is proton and neutron. So outside, in the first energy level, there is S. So there is S. What is the shape of S? Circle. Now inside the circle, there are 2 electrons. So there is a 2 electron, I don't know where, just inside that circle, or that orbit S, there is now 2 electrons inside, but I cannot know where is that located. They're just moving around there. And the next one is 2s2. Again, in the second energy level, so that is bigger. Okay, 2 is bigger than 1. So outside beryllium, outside the nucleus, there is the second energy level and it is shaped as circle. So this is the first energy level, this is the second energy level. In the second energy level, there are 2 electrons, but I cannot really pinpoint where is that located. Now, what if there is a continuation? This is not beryllium anymore. Okay, that is not beryllium anymore. What if, let's continue this one. 1s2, 2s2, 2p6. Okay, on the same energy level 2, there is the P shape. P can be PY, PX, or PZ. So let's assume that the P is oriented as PY. Okay, PY. Oriented as PY. So on the same energy level, so let's assume there is this axis over here. Let's assuming only, okay? So there is P on the same energy level P. And inside that P, there are 6 electrons. 1, 2, 3, 4, 5, 6. I cannot really pinpoint where is it located. Now, how about let's continue. 2p6. What is next there? 2p6, 3s2. How about there is another 3s2? Okay, on the third energy level, there is S. So, third energy level, what is the shape? S. Circle. Third energy level, there is S. Inside that orbit, there are 2 electrons, but I cannot really pinpoint where is it. I just assume that it's there, but they are really moving around. Next, we have another 3p6, the next one. On the same energy level, there is P. Let's assume that the P is oriented like X, PX. So on the same energy level, there is PX. And then inside that P, there are 6. 1, 2, 3, 4, 5, 6. Okay, inside there are 6. But I cannot really tell where is the specific location of that. It's just inside that dumbbell shape P. What is next until 3p6? We have 4s2. Okay, on the fourth energy level, there is circle because it's 4s. S is circular. So inside that orbit, there are 2 electrons. What is next to 4s? There are 3d. 3d10. Okay, what is the shape of d? So it's the same. On the third, okay, because it's 3d10, on the third energy level, we have the D shape. So on this part over here, so D, let's say clover shape, 1, 2, 3, 4. Inside that clover shape, there are 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why it looks like an electron cloud. So an electron cloud will look like this. So if you will continue and you have F, of course there would be some F shape here, like 1, 2, 3, 4, 5, 6. So it's like an electron cloud. Okay, it's somewhat confusing, but an atom will really look like this. So if you're going to draw your atom, it doesn't really look like this na parang ganyan lang siya. The electrons is simply moving. No, but there are shapes actually for each orbits. Okay, so there. I hope you understand the electron cloud model using the different shapes that was provided.